Hello class, welcome to lesson 8.10 or 810. It is all about systems of equations. Okay, so systems of equations is a group of two or more equations with the same variable. For a system with two variables, solutions are written as an ordered pair. Okay, so the solution should show where the lines intersect. So if I give you a graph that looks like this, my solution is where those two lines intersect. So where the orange and the green line intersected, that would be my solution. So since that's a point on a coordinate plane, it can be written as an ordered pair. And so that would be my answer. So let's practice solving these systems of equations by graphing. Okay, so if I look at the very first equation, I have y equals x. Okay, so how do I graph y equals x? This is like having a plus 0 there. So I know my y-intercept is when y equals 0. And then if I look at my x, this is like 1 over 1, or 1x. So that means I'm going to go up 1 over 1 in the positive direction both times. Or I can go down 1, left 1, negative both times, because the negative 1 divided by a negative 1 is also positive. So then if I connect all of these dots, I know I have the graph of y equals x. Next, I want to graph y equals negative 3x plus 4. So I look, this is always going to be my y-intercept. So I look, where is y a positive 4? That would be right up here. And I look, I have a slope of a negative 3. So that means I can go down 3, right 1, down 3, right 1. Or I can go up 3, left 1. Okay? And then I'm going to connect these dots in order to get the graph of my line. So I know the solution for this problem is where the two lines intersect, which is right there. So my solution is 1, 1. Okay, let's try another one. So again, I'm going to start just by graphing this problem. I have y equals 1/2 x minus 6. I start with my y-intercept. I go down 6, put a dot, and then I look at my slope. I have a positive 1/2. So I'm going to go up 1 over 2, because remember it's rise over run. Oops, I went over 3 that time. Up 1 over 2, up 1 over 2, 1 over 2. Okay, so then I just have to connect these dots, and I have my new graph of that line. Next, I'm going to graph my y equals negative 3x plus 8. So I start up at 8. I go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. Okay. So even though I might have already seen where these two lines are going to intersect, ooh, that was a bad start to the line, I still need to graph both of the lines, okay? Then I look, where do they intersect? They both hit this coordinate right here, which is going to be 1, 2, 3, 4, because x is written first. And then I'm going down 1, 2, 3, 4. So 4, negative 4. One way to check is if you plug these coordinates in. So instead of y here, I'm going to put negative 4 equals 1/2 times 4 minus 6. So what's 1/2 times 4? That's 2. So I have a negative 4 equals positive 2 minus 6. Is that true? Yes, I know that's true, and I could have checked it down here too. I could have said negative 4 equals negative 3 times 4 plus 8. So this is a negative 12 plus 8. Is negative 12 plus 8 negative 4? Yes. So I know my answer is absolutely correct, and I can move on without questioning. So let's try graphing another one. This time we have y equals negative x minus 6. Let's start at negative 6. And if we have a negative x slope, it's like a negative 1. So if I go down 1, right 1, that's going to give me a negative slope. Or I can go up 1, left 1. Okay. And if I connect all of these lines, sorry, my lines are not the best today. If I connect all of those, there's my graph. Now, if you look at the next one, I have x plus y equals 1. That's not as easy to graph for us. We've been practicing graphing in the y equals mx plus b form. So let's get y by itself. So let's move x. So I have y equals negative x plus 1. So if I go up to a positive 1 for my y-intercept, then my slope is a negative 1 again. Okay, I'm going to connect all of these. And that is going to tell me about this graph. Okay. Well, this is interesting because my graphs don't touch. So if the graphs don't touch, what can we assume about our solution? If the graphs are parallel like this, lines don't touch, then you can assume that there is no solution. Okay? If you end up with two parallel lines, you're going to say that it is no solution. Okay? It's very, 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 very important. Please make sure you have that written down. Okay, let's try another one. So we have y equals 2x plus 4. So I go right to my y-intercept, and I say I have a slope of 2. That's up 2 over 1, up 2 over 1. Or I can go down 2, left 1, because that means they're both, it's a negative 2 over a negative 1, which that's just a positive 2 as well. So now if I connect all of our dots, I have our first graph. Now our second one, I have 1/2 y equals x plus 2. I want my y to be by itself. So instead of multiplying by 1/2, let's divide by 1/2. Which, remember, dividing by a fraction is the same as multiplying by the reciprocal. Okay? So we're going to have y equals, I have to multiply everything on this side by that 2. So I have 2x plus 4. Okay, so now I look, 2x plus 4. Well, this looks vaguely familiar. That's going to be that very same line. So what does it mean when we end up with the same line that we started with? If when the graphs didn't touch at all, that was a no solution. Now when the graphs are the same line, that means they are all solutions. Okay? Your answer will be all solutions when you end up graphing the same line. Okay, that's another very important thing. So let's make sure you have that written down. Let's look at this word problem. We have Maggie and Brian are selling magazines. Maggie sells 3 times as many magazines as Brian. Brian sells 9 fewer magazines than Maggie. Write a system of equations to represent the situation, then graph the equations to find the solution. Okay, so Maggie and Brian are selling magazines. Maggie sells 3 times as many magazines as Brian. So let's say we have x, and Maggie sells 3 times as many as Brian, right? So we can say y equals 3x, but that means x means Brian, and that would mean y equals Maggie, right? Because Maggie sells 3 times as many magazines as Brian. But we also know that Brian sells 9 fewer magazines than Maggie. So we still want to keep our equation somewhat in the y equals mx plus b. But if we know that Brian sells 9 fewer magazines than Maggie, we can say Maggie sold this many, Brian sold 9 fewer. That means we're going to subtract, and that equals Brian. Well, let's get y by itself. So if we add 9, y equals x plus 9. So now all we have to do is graph. This y equals 3x, that's like having a plus 0. So I put my first dot at the origin. I go up 3 over 1. Or I can go down 3 left 1. And I connect those. And then I have a y equals x plus 9. So I go up to 9 and I graph that. Or if we look, this is going to be off our graph where they meet, right? So let's adjust. Let's change our scale. Instead of going by 1s, let's maybe say that we are going by 3s. Okay, so let's try graphing the y equals 3x plus 0 again. So we have point at the origin, and we're going up 3, so that's my first line now because I changed the scale, over 1. So this is what that first graph will look like. Okay, and let's try graphing that second one now. We have y equals x plus 9. So I start here and I go up 1 over 1. That's going to be right about in there. We go up 1 over 1, up 1. Oops, that should be a little bit. I'm going to adjust a little bit. Okay. So if we look, my graph should look something like that. Okay? So that is how you would solve that problem. Okay? Let's practice a couple other things. What if we are told to use something called substitution? Substitution is a method to find the exact solution for a system by replacing one of the variables, okay? So let's practice that. We have y equals x plus 2 and y equals 5. Okay, so whenever you have a variable equals a number, and that same variable is in the other one, all you're going to do is replace it. So we're going to say 5 equals x plus 2, and if we solve that, all you have to do is tee it up, subtract 2 from both sides. We have 3 equals x. So we know that y equals 5, because we were told that, x equals 3. Okay, let's try one more like that. We have, oh, this got a little messed up. That should just be y equals 1. I'm not going to mess with it right now. Okay. So we have y equals 1, and we have y equals 6x plus 7. So again, we have a y here, a y here. Let's replace these numbers. So we have 1 equals 6x plus 7. So 1 equals 6x plus 7. Tee it up again. Let's get x by itself, so let's subtract 7 from both sides. We have a negative 6 equals 6x. Keep going. In order to get x by itself, we're going to divide both sides by 6. I have negative 1 equals x. So x equals negative 1, y equals 1. Okay, so all you have to do is plug things in. Alright, so here's your assignment for today. Go ahead and do page 456, numbers 8, 9, 11, 12, then do 14 through 19 all. I hope you guys have a great day.